Okay, so let's talk about exponential rules. I got these rules from sciencenote.org. Very nice place. Go check it out if you need any mathematical notes. Okay, first things first. Let's keep it easy. The zero rule. Anything to the power of 0 is equal to 1. Okay, that's it. So 1 million. What's that? 1, 2, 3, 4, 5, 6. Oops. 1 million to the power of 0 is equal to 1. A, B, C to the power of 0 is equal to 1. And even 0 to the power of 0 is equal to 1. Okay, very simple. Anything to the power of 0 is equal to 1. That's the first rule. Second rule is the product one, where you have, let's say we're given some x squared multiply x to the third. All you're going to do is you're simply going to add the exponents together. Okay, very simple. 2 plus 3 is 5. Let's do another one. x22 times x12. Well, what can that give me? Simply going to add 22 plus 12. That gives me 34. X to the power of 34. This would be the product rule. Okay, the product rule. Okay, let's go to the quotient rule. Okay, the quotient rule states that x to the 5 divided by x to the 2, or x to the second power, simply means 5 minus 2, which gives me x to the 3. So all you can simply do with the quotient rule when you see division with exponents, you just subtract them from one another. Okay, let's see how that looks look in theory. So it's going to be 1, 2, 3, 4, 5 over 1, 2, 3. This is what this means, right? So I can rewrite this as x to the power of 5 over x to the power of 3. So let's see what happens. Now I can cancel one of them since they're the same value or the same variable. I can cancel another one. I can cancel another one. We see that we are left with x squared. Now we can conclude now that 5x5 minus 3 is also x squared. So we know that this proof works, or this method. Okay, now we have a power of a power of a product, which simply means if I have a, let's use x and y, x times y inside of a parentheses raised to the 7th power. All this means is that I'm going to distribute the property and multiply it with whatever exponent is on top of my variable. Okay, this means 7x to the power of 7 times y to the power of 7. Very simple. Let's do another example. Let's say we have x2, y3, and we want to raise this to the 3rd power. I'm going to multiply and multiply. Okay, so it looks something like this: 2 multiply 3 and y3 multiply 3. That gives me x to the 6th power and y to the 9th power. Okay, we're almost done. So power of a power, I pretty much just explained in this case. So here we have power of a product, and then this one would be power of a power, which just means if you see some variable or some exponent on the outside, you just multiply it with the exponent on the inside. Very simple, okay? Don't overcomplicate it. What about a negative exponent? Well, let's say I have x to the power of negative 1. I can rewrite this as 1 over x. Let's say I have 1 over x squared. I can rewrite this as x to the power of negative 2. So the idea is to just change your exponent always to positive, and we can do that by switching it between our numerator and our denominator. Okay, the top of a fraction is known as a numerator, and the bottom of a fraction is known as a denominator. So we can swap it up and down. Okay, a very, very simple explanation. Let's do an example. Let's say we have x to the power of negative 2 over y to the power of negative 3. Remember what I said? We can swap this to the top. So this simply gives me y to the power of 3 over x to the power of 2. Let's do another one. X to the power of 2 over y to the power of negative 2 times x to the power of negative 2. What do we do now? Well, let's rewrite it. This gives me x to the power of 2, this part, times y to the power of 2. Remember, I just made it positive by bringing it up. Very simple. And then we have x to the power of 2. Now we know if we have two exponents that multiply, we're going to simply add them together. So my final answer would be x to the power 4 times y to the power of 2. Okay, then we have a final one, fractional exponent. Now this one is maybe the most complicated one. So let's say we have the square root of x. There's some values that's missing here that's not written in. So let me write it. So there's x to the 1, and square root would have a 2 root, okay, a second root. So I can rewrite this as x 1 over 2. You take whatever values here, you make it the numerator, and you take whatever values there, and you make it the denominator. So this is the denominator value, and this one will be the numerator value. Okay, let's do another example where we have, let's say we have y to the 4, and we have the 10th root of y. We can rewrite this as y 4 over 10. Now this is very useful for when you get to temperature calculations in physics, where you might have to rewrite temperature and square root some values, so you get like t raised to the 1/4 power. So in physics this plays a fundamental role, especially in calculus too, which if you are taking college algebra, calculus will probably follow. So yeah, now, so let's say this one is just t and this is raised to the 4th. Okay, so we can rewrite this as t 1 over 4. Okay.